Hello ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss exponents and division. So look at example 1. We want to talk about dividing powers with the same bases to produce positive exponents. You can use repeated multiplication to simplify fractions. Expand the numerator and the denominator using repeated multiplication. Then we're going to cancel out like terms. So let's look at the first example. 5 to the 6th power divided by 5 to the 2nd power. Let's first expand that. So 5 to the 6th power means 5 times 5 times 5 times 5 times 5 times 5. Okay, you have 6 5s over 5 to the 2nd power, 5 times 5. So we're going to cancel it out because when you have the same numerator over denominator equals 1. So let's cancel out our 1 5s because that equals 1. And let's cancel out our second set of 5s. So what do we have left here on the top? We have 5 repeated 4 times. Therefore, our answer is 5 to the 4th power. Let's look at the next one. Complete the following: 3 to the 7th power over 3 to the 2nd power. So let's write 3 to the 7th power. That's 3 times 3 times 3 times 3 times 3 times 3 times 3 over 3 to the 2nd, 3 times 3. And now we're going to cancel it out. So 3 over 3 because that equals 1, 3 over 3 because that equals 1. And you're going to say, what are you left with? We're left with 5 3s. So your answer would be 3 to the 5th power. Let's look at number 2, the next one. Complete the following: 7 to the 5th power divided by 7 to the 3rd power. So let's first expand it. We have 7 times 7 times 7 times 7 times 7. That's 7 to the 5th power over 7 to the 3rd power. 7 times 7 times 7. Let's cancel it out. Remember, because it equals 1. So we cancel out 1, 2, and 3. And then what do we have left? 2 7s. So your answer is 7 to the 2nd power. So now let's determine the relationship between the exponents on the 2 original exponents and the exponent of the final answer. What did we notice we did? Well, we subtracted our exponents. They're like bases, and we subtracted the exponents. So we noticed that when we had like bases, we subtracted our exponents. So what is our key concept here? Our key concept is to divide non-zero numbers or variables with the same non-zero base, we're going to subtract the exponents. So our key concept is to divide non-zero numbers or variables with the same non-zero base, so same bases that can't be 0, we subtract our exponents. So let's look at our arithmetic example, an example with numbers. If I had 2 to the 4th power divided by 2 to the 2nd power, what I'm going to do here is I have like bases, they're both 2, so I'm going to subtract my exponents. So I'm going to say 2 to the 4th minus the 2nd power. Therefore, my answer is 4 minus 2 is 2. My answer is 2 to the 2nd power. 2 to the 2nd power, also known as 4. So let's look at the algebraic example. Algebraic is with variables. So if I had a to the m power over a to the nth power, I want to subtract my exponents. So I would say a to the m minus n power. Now, the note here is to note where a cannot be equal to 0. Where a cannot be equal to 0. Okay, that's important. Why can't a be equal to 0? On the bottom, we talked about this. If it's 0 on the bottom, it would be undefined. So remember, if a denominator is equal to 0, then it is undefined. and that's why a cannot be equal to 0. So now let's do some examples together. So let's read the directions. It states, write each expression using a single exponent. So the directions want it in a single exponent form. You do not need to evaluate it. So we have 8 to the 5th power divided by 8 to the 3rd power. So we have like bases here. So we're going to rewrite 8 and then just subtract our exponents. 5 minus 3. Therefore, 5 minus 3 equals 2. So my answer is 8 to the 2nd power. Let's look at number 2. We have negative 9 to the 32nd power divided by negative 9 to the 15th power. They are the same bases, so we can subtract their exponents. So negative 9 stays in the parentheses, and then you're going to say 32 minus 15. And what is 32 minus 15? It equals 17. Therefore, your answer is negative 9 to the 17th power. And that is your answer. Let's look at number 3. It says m to the 12th power divided by m to the 5th power. Again, they have the same bases. They're both m. So we're just going to subtract our exponents. So we're going to say m, and we're going to say 12 minus 5. Therefore, my answer is m to the 7th power. So we divide the same bases with exponents. You're just subtracting your exponents. So what I'd like you to do is the you try section. Please complete numbers 1, 2, and 3, and we will discuss it in class. Thank you.